As a mechanical engineer working in HVAC, one of the most common questions I hear is, how should we switch a heat pump system from cooling to heating, or from heating to cooling, in multifamily buildings, commercial projects, or apartment complexes? This question typically comes from property owners, BMS agents, mechanical contractor, general contractors. Before diving into the answer, let's first take a look at a sample heat pump schedule. Based on the schedule, it is evident that this 4-pipe air source heat pump system operates in both cooling and heating modes. The system is designed with a dedicated cooling loop, supply and return, and a dedicated heating loop, supply and return. In cooling mode, the system is set to maintain a supply water temperature of 45 degrees Fahrenheit, while in heating mode, the set point is 145 degrees Fahrenheit. The system consists of 2 heat pump banks, each requiring 350 GPM of water in cooling mode and 145 GPM in heating mode. To prevent freezing, the water is mixed with 30% propylene glycol. The system is designed to deliver an EER of 10.36 in cooling mode and a coefficient performance of 2.68 in heating mode. In the summertime, several heat pump modules operate to meet the terminal cooling load, while additional modules run to serve the domestic hot water (DHW) system through the potable heat exchanger. The blue lines shown here represent the cooling terminal loop, while the other loop supplies the DHW heat exchanger. In the wintertime, several heat pump modules supply hot water to the terminal load loop heat exchanger, while others continue to serve the domestic hot water (DHW) heat exchanger. Instead of sending hot water directly to the terminal unit heat exchanger, the system uses this intermediate heat exchanger to isolate the glycol loop from the water loop on the load side. Now, coming to the main question, how should we switch the mode from cooling loop to hot water loop during winter for the terminal load loop? In multifamily or commercial systems, you don't flip between heating and cooling in a moment. There's always a buffer period to stabilize water loop temperatures and protect compressors. Heat pumps have a safe operating envelope. For example, before switching to heating, the loop temperature must be raised above 75 degrees, but in summer, the loop temperature was around 45 F. We have to have some means, sometimes using boilers or supplemental heat for a few minutes, to raise the loop temperature above 75 F. That will allow the heat pump to run within its operating envelope, and it will not see any issue on the field. Otherwise, the heat pump will go on alarm of out-of-envelope alarm or some pressure alarm. Similarly, when switching to cooling, the loop must be cooled below a threshold. In summer, it's comparatively easy to switch the terminal load loop. If you run the terminal unit for a couple of minutes, there will a heat loss in the secondary side of the glycol loop heat exchanger. Ultimately, primary side loop temperature will go down so that you will have loop temperature below 65 F to run the system. Ultimately, the mode changeover process takes time. It is not as simple as issuing a BMS command to switch from cooling to heating or vice versa. A proper changeover requires a clear understanding of the system and careful management of the loop temperature to bring it within the compressor's operating envelope for the selected mode. It is important to review the mode changeover procedure with the heat pump manufacturer's representative, obtain their approval, and, if possible, document the process in writing for future reference. Thank you for taking the time to watch this video. I hope the information was helpful in understanding the heat pump mode changeover process. If you found this useful, please like the video, share it with others, and subscribe to the channel for more HVAC insights and technical discussions.